All right, so starting with the DILR section, this was slightly moderate level paper. It was not very easy to pick the sets. Rather, the sets were not very easy to solve. Probably 1 or 1.5 set were doable in this. If you put in a lot of effort, 2 sets. So that's how I would rate this paper. Definitely not an easy paper. Let's go ahead and start with the first set. So if you're talking about the first set, the first set over here is actually a Venn diagram, set. But the problem in this particular set is it would give you multiple possibilities, and you have to get all the possibilities for you to get the correct answer. The second bigger problem is getting the possibilities is not easy in this. Right? So this is a set where it's a lot of numbers. You have to play around with the numbers. A little bit of hit and trial if you don't get the right logic, and that is the reason why I would definitely rate this as a set that you should have left in the exam. Let's go ahead and take a look at why am I saying so. So you're talking about voting happening for 3 people, 3 of the greats in tennis: Federer, Nadal and Djokovic. And the people who neither voted for any of the 3 or voted for all 3 are 5 and 14 respectively. It is given that the total number of people who voted was the minimum possible, which also means you are looking at minima maxima in this. So there are a lot of things which are combined in this set. Hence, I would have recommended you to leave this set, but let's go ahead and see what makes this set even more complicated. The third point says the people voted in such a way that the number of people who voted for all the different possible combinations of players, which means if you're looking at a Venn diagram of 3, then A, B, C, D, E, F and G. So he's talking about each of these values, A, B, C, D, E, F, A, B, C, D, E, F, G. They are, when divided by 8, gave all possible whole number reminders exactly once with distinct whole numbers as quotient. And of course you have an H outside also. This H is given to you as 5. This G is given to you as 14. So now what he's saying is each of these numbers are in such a way that when you divide by 8, each number will give you a distinct quotient and a distinct remainder. For example, if you take 5, when you divide by 8, you will get quotient 0 and remainder 5. If you take 14 when you divide by 8, you will get quotient 1 and remainder 6. Right? So like that, each one of these numbers have a distinct quotient and a distinct remainder. Now remember, what are the reminders? Reminders can be 0 to 7. And what will be the quotient? Quotients can be 0 to 7, 8. It can go to any level. But since we are trying to reduce the total, because we are looking at minimum possible, I'm assuming that it can be from 0 to 7. Maybe 8 also possible. I don't know. Depending upon how the numbers fit. But we are looking, normally if you want to reduce the numbers, the quotient should be lower. That's the logic. Let's go ahead and take a look at the other parts of the numbers. The number of people who voted for exactly one player was 103, and the number of people who voted for Djokovic only was 50. The number of people who voted for Nadal was more than the number of people who voted for Federer, but it was not a perfect square. The number of people who voted for Nadal is greater than those who voted for Federer by 1. So let's go ahead and try to fit these points in the Venn diagram. So I have Federer, Nadal and Djokovic. It is given this as 5, and in brackets I'll write the coefficient and the remainder. Here I have 14. In brackets I will write the coefficient and the remainder. Remainder is 6. And it is given that this is 50. So the coefficient is 6. And sorry, not coefficient, quotient. Quotient is 6 and the remainder is 2. Now I have, if I take this as x. Now remember, it is given to us that only one player is 103, out of which 50 is already written. So the remaining should be the remaining only Federer. Federer only plus Nadal only should be 53. If this is x, then therefore this will be 53 minus x. Okay, it is also given to us that the number of people who voted for Nadal only is more than those who voted for Federer only. So 53 minus x is greater than x, or 53 is greater than 2x, or 26.5 is greater than x, which basically means my x is less than or equal to 26. So x should be less than or equal to 26. Also, please keep in mind 53 minus x is not a perfect square. It is not of the form of p square, because it is mentioned that it is not a perfect square. Okay, so now the question is, how do we go about doing this? And we also have the number of people who voted for Nadal is greater than those who voted for Federer. So from here onwards, the questions, the solving becomes a bit complicated. You have to be very careful in solving. So first, start looking at the reminders. The reminders that are completed are the reminders possible are 0, 1, 2, 3, 4, 5, 6 and 7. In these reminders, 2 is already gone, 6 is gone and 5 is gone. So now I am left out with these reminders. Great. Now let's look at this and this. Okay. If you look at x and 53 minus x, if you add them both, you get 53. Divide 53 by 8, what do you get? If you divide 53 by 8, the remainder will be 6 8s are 48. The remainder should be 5. What does it tell you? Two numbers, when you add, gives you a remainder of 5. It means the remainder of each one of these numbers when separately added should also give you 5. So x when divided by 8, x when divided by 8 should give you a remainder r1, and 53 minus x by 8 should give you a remainder r2. These should be in such a way that r1 plus r2 when added up should be equal to 5. Now let's take a look at the left out remainders. Which remainders are there such that the total adds up to 5? Only these. Remainder 1 and remainder 4. No other remainders are left out to add and give you a total of 5. Which means your x can be in the form of 8k plus 1, or it can be in the form of 8k plus 4. There are two possibilities, and accordingly this 53 minus x will be adjusted. So let's start with 8k plus 1. If it is 8k plus 1, let's look at the possibilities for x. Starting with k equal to 0. So x can be 1. Therefore 53 minus x will be 52. Okay. But keep in mind x should be less than 26. Now the next possibility is when k is 1. So x is 9. So this will be 43. Right. This is 43. No, 44. 44. Right. Then we have the next number will be 9 plus 8, which is 17, and 44 becomes 36. Now next will be 17 is getting added. You are going to add 8 to 17, so this is 25, and the next one will be 25, so this will be 18. Okay. Now after this you don't have to go, because if you go further by plus 8, you're going to cross 26 and your x is supposed to be less than or equal to 26. So you don't have to go beyond that. Stop here. Now analyze. If it is 1 and 52, is it possible? 1 and 52, let's look at quotient. Quotient is 0, remainder is 1. Quotient is 0, remainder is 1. In this case, 6 8s are 48 and 4. Now please remember 6 is already done. Quotient 6 is already gone. So this is not possible. Now let's look at 9. Quotient is 1, remainder is 1. And 44, quotient is 5, 5 8s are 40 and remainder is 4. Okay. Now maybe 9 and 44, is it possible? Now not possible. Why? Because the quotient 1 is already gone. So 9 and 44 is not possible. If you look at 17 and 36, 8 2s are 16. So quotient 2 and remainder 1. And 36 not possible. Why? Because 53 minus x is not a perfect square. Hence this is gone. It's not supposed to be a perfect square, whereas 36 is a perfect square. So 53 minus x cannot be a perfect square. So that is gone. Now if you look at 25 and 18, 8 3s are 24 and remainder is 1, and 8 2s are 16 and remainder is 2. Now quotient is 2, remainder is 2, remainder is already 2. We got remainder as 2, so this is also not possible. So in the form of 8k plus 1, you don't have any possibilities. So then let's take a look at what happens if it is in the form of 8k plus 4. So let me quickly write 8k plus 4 as a possibility. I'm just erasing this to get some space. Okay. So now if I have 8k plus 4, now let's start with the k value as 0. So x will be 4, in which case this will be 49. Now is it possible? Coefficient is 0, remainder is 4. And 6 8s are 48, so quotient is 6, remainder is 1. 48 plus 1, 49. Now this may be possible, 0, 4 and 49, 0 and 4. Yes, may be possible. Now let's go ahead. Then we have 12 and 49, this is 41. Let's finish everything. Then 20 and 33. Then you have 28. So 28 you don't have to go, because again you're looking at numbers which are less than 26 only. So let's finish off everything. So this is 5 and remainder 1. This is 8 4s are 32, remainder 1. This is 8 1s are 8, remainder 4. And this is 8 2s are 16, remainder 4. Now remainder 4, all of them are remainder 4s, and here all of them are remainder 1s. And what about quotients? Quotient 1 is not possible because quotient 1 is already gone, so this is ruled out. What about quotient 2? Quotient 0 is also not possible. Why? Because 0 quotient is already here, 0 and 5. So we have only one possibility. X should be 20. This therefore will become 33. So now let's go ahead and make possible cases. So I have 20, 33, this is 14, 5 and 50. Let me also write the quotients, 0 and 5 remainders. This is 6, 6 is the 48, 2, 8 1s are 8 and 6, 8 2s are 16 and 4, 8 3s are 8 4s are 32 and 1. Okay, these are correct. Now the question is, we have A, B and C. How do we get your A, B and C values? So now we will use this part of the statement. The number of people who voted for Nadal is greater than those who voted for Federer by 1. So this is my Nadal, Federer and Djokovic. So if I total up Federer will be 33 plus C plus 14 plus A should be equal to, I think Nadal is, the number of people who voted for Nadal is greater than those who voted for Federer by 1. So Federer plus 1 should be equal to Nadal. So Nadal is 20 plus A plus 14 plus B. Anyway, 14 gets cancelled. A and A gets cancelled. So what do you get? You basically get 34 minus 20. 33 plus 1, 34. 34 minus 20, 14 is equal to B minus C. Okay, I think I made a small error. This I took it as Federer actually, and this was Nadal. So let me just correct myself. I made a mistake with Federer and Nadal, because originally I started with the left hand side circle as Federer and the right hand side circle as Nadal. So I hope you guys remember this. F was on the left, this was F and this was N. So let me go back. So Federer is greater than Nadal. That's what it says. Nadal is greater than Federer by 1. So Nadal is 33 plus A plus C plus 14 is equal to Federer plus 1, which is 20 plus 14 plus A plus B plus 1. So 14A gets cancelled. Therefore, I'll be left with 33 minus 21. So I'll be getting 33 minus 21, 12 is equal to B minus C. So whatever B and C, the difference should be equal to 12. And also keep in mind what are the remainders which are left out. Remainders that are left out, 0 is left for me, it's not used. I'm talking about reminders. Okay. Then remainder 1 is gone. Here 1 is gone. Remainder 2 is gone. Remainder 3 is left. Remainder 4 is gone. Remainder 5 is gone. Remainder 6 is gone. So remainder 7 is left. Now the difference of these two is 12. So when I divide 12 by 8, my remainder is 4. Therefore, when B's remainder and C's remainder are subtracted, I should be getting an answer of 4. So what could be the possible values of B and C? The B and C should have remainders 3 and 7. Because 3 minus 7 or 7 minus 3 is 4, depending upon which is bigger. So you are basically looking at B and C having remainders 3 and 4. Therefore, this definitely should be having 0. So A should definitely have the remainder 0. 3 and 7 couldn't go to B or C or B. Okay. So let me just write down the values. So let me take remainder 7 here. Right. and remainder 3 here, and see what happens. And also now look at what could be the, so these are remainders. Now let's look at the quotients. What are the quotients which are left out? Quotient 0 is gone, quotient 1 is gone, so 0 is gone here, quotient 1 is gone, quotient 2 is gone, quotient 3 is left out, quotient 3, quotient 4 is gone, quotient 5 is left, quotient 6 is gone, quotient 7 is left. And these are the quotient. Now remember, B minus C is 12, so B is greater than C. So now what could be the possibilities? If you take this B as having remainder quotient 5, then you can only put 3 here, you can't put 7, because if you put quotient 7, then C will become greater than B. But then if you notice here, basically this means the number here is 47, right? And the number C will therefore become 8 3s are 24, 24 plus 3 is 27. Now the difference is not 12. Similarly, if you try to put, instead of 5, if you try to put 7 and 5 again, you will again see that the difference will be a number ending with a 0. But you want the difference to be 12. So basically, where did we go wrong? We went wrong in taking 7 as remainder for B and 3 as remainder for C. So now let's swap it. I will take remainder 3 here and remainder 7 here. Now what could be the possibilities? So let's start looking at the possibilities. Again, B should be greater. So I will put 5 and 3. Is it possible? So in this case, 8 5s are 40. So this is 43. And 8 3s are 24. 24 plus 7. That is 30. 84 plus 7. 31. And therefore, if 5 and 3 are gone, this will be 7. 7 8s are 56. Now 43 minus 12 is 31, or 43 minus 31 is 12. Perfectly possible. Okay. Now let's look at other possibility. Is there another possibility? Yes. What could be the other possibility? So this is 33, this is 50. So again, this will be 3 remainder and this will be 7 remainder. And this is 14 anyway. 14 is confirmed. And now we have this part which is 0 remainder. Now what else could be the possibility? Can I have 7 and 5? Can I have 7? 5 and 3 I used. The next possibility is 7 and 5. Please remember, I can't check 7 and 3. I don't have to check 7 and 3 because the difference, if I put 7 here and 3 here, okay, if I put 7 and 3 as quotients, then the difference will be much bigger than 12. So I don't have to check for 7 and 3. So it has to be 2 successive quotients. So it's either 7 and 5 or 5 and 3, 2 possibilities. So if it is 7 and 3, 7 is 56 plus 3, 59, and 8 5 is 40, 40 plus 7, 47, sorry, 47, not, it's 47, and therefore I'll be left with the coefficient 3 here, sorry, not coefficient, quotient 3 here, so 8 3s are 24. So now I got 2 cases. Which case should I select? The condition given to me is the total number of people who voted was the minimum possible. So let me see what are the totals. The total for Federer, Nadal and Djokovic, and this is 5 which is common for both. So I will have to look at the individual totals. Now 20, 33, 50 is common for both. 20, 33, 50. So and 14 is also common for both. So I will only have to check the total of 59, 24 and 47. So 59, 24 is 70, 79, 83. 83 plus 47 is 120, 130. Similarly, if I look at 56, 43 and 31, 50 plus 40 is 90, 99 plus 100 and 130. So you see that both cases, the total number of things are exactly the same. Hence, both cases are valid. So now in both cases, what is Federer total? Federer's total is, you'll have to just add them up. So let's put the, let's add and put them up. 59 plus 24. 50, 60, 70, 79, 83, 93, 103, 113, 117. And Nadal's total here will be 40, 50, 60, 70, 80, 90, 100, 110, 118. And Djokovic's total here will be 50 plus 50, 100, 100, 140, 150, 161, 170. All right. Similarly, if you do the totals for Federer, Nadal and Djokovic in the other case, you will get 133, 134 and 138. Now the entire set is solved. So let's go ahead and answer the questions very, very quickly. How many people voted for Federer and Nadal but not Djokovic? So Federer and Nadal but not Djokovic. It could be either 24 or it could be 56. Therefore, the answer here will be either C, either 24 or 56, which is option C. Okay. Next question. Among those who voted for Djokovic, what was the absolute difference between those who voted for Federer and Nadal? So basically, we are looking at Djokovic plus Federer and Djokovic plus Nadal, the difference between these two. Right, so Djokovic plus Federer, Djokovic plus Nadal. Let's take a look at it. So Djokovic plus Federer, this is 59, and Djokovic plus Nadal, this is 47. In whichever case you take, the numbers are different, but the difference is exactly 12 in both. Basically, it is B minus C. B minus C is 12. So therefore, you have the answer for this particular question, the answer as 12. Right? Next, how many people voted for Djokovic in the voting? Now, Djokovic, we got total. There are two totals, I believe, that we got. What are the two totals? I think, yes, we have here 170 is one and 138 is one. So the answer is cannot be determined because we exactly don't know what is it. We got both 170 and 138. Both are possible. Therefore, the answer is cannot be determined. Question number 4, the number of people who voted for only Nadal exceeded those who voted for only Federer by what number? The only Federer and only Nadal, the difference. Okay, so we just have to look at the cases. Only Federer is 20, only Nadal is 33. In the first case, the difference is 13. In the second case also, basically it's the same number, so 20 and 33, the difference is 13. Therefore, the answer in that particular question is 13. And the last question, which of the following statements is not true? The number of people who voted for Nadal and Djokovic but not Federer was a prime number. So basically people who voted for Nadal and Djokovic but not Federer. So let's go ahead and take a look at it. Nadal and Djokovic. Where are we? Nadal and Djokovic but not Federer. So basically that is 31 or 47. 31 and 47 both are prime numbers. So the question, the statement says, which of the following statement is not true? Okay, this is true. This is true. So this is not your answer. So clearly A is gone, B is gone, and D is gone. So therefore you will be left with option C. So here we don't even have to look at second and third options or the second and third statements. You get the answer straight away. All in all, this set is a bit confusing, time taking, not something that you should have picked up in the beginning. All right.